Have you ever desired to go back in time and get to know outstanding historical figures, or even travel to the future and take a look at the new technological advancements? Are you as passionate as me when it comes to physics? Well, good news. This video is definitely for you. To fully understand how time travel works, it is important to review Einstein's special theory of relativity. The theory has two parts, or postulates. The first part simply states that the laws of physics are the same in all inertial frameworks. This means that in these frameworks, there's dot and abroad, acceleration or deceleration. The speed is constant. All speed is relative to its framework. For instance, let's take a static phone and that same phone as I walk. As you can see, the phone is not moving. In both cases, the phone did not move. The speeds were different, but the laws of physics were the same. The second postulate states that light speed is constant in a vacuum, regardless of whether the source of light is coming from or if the observer is moving. This is because light travels through space, which is simply empty. As a result, Einstein concluded that there's no such thing as an absolute movement. Based on both postulates, Einstein determined that time and space are relative, a result of simultaneous events. For example, today at 5 p.m. Barcelona and Real Madrid are playing against each other. But what I really mean is that when my watch is at 5 p.m., then the game will start. However, remote events on my watch, such as the day in which I was born, do not serve the purpose of connecting a series of events with time because they're not simultaneous. Additionally, based on this theory, Einstein determined that there's nothing faster than the speed of light, and this is where time travel comes into place. If the speed of light was reached, then individuals could travel to the future. This is because as one approaches light speed, time becomes static and time dilation takes place. This simply states that as one gets closer to light speed, then time slows down. For example, an astronaut tends to perceive 30 years in Earth as just one in space, which is attributed to time dilation. Moreover, based on the special theory, it is impossible to go back in time. However, in this case, let us use the general theory, which will allow us to go back in time by creating a wormhole between points in space and time, and light speed would be overcome by a particle accelerator, which would accelerate elementary particles to a very high energy. Imagine this line is time, and as you overcome light speed, time stops and you are able to go back. But if you change any event, then an alternate reality will be created. Consider this alternate reality as a type of multi-universe in which it occupies the same place in space but vibrates at a different frequency. The realities cannot interact. Time travel is a complicated task, but once we accept our limits, we go beyond them.